Everyone, this is lesson 8.5 on trapezoids and kites. So we're first going to learn about the properties of trapezoids. So a trapezoid is a quadrilateral, so four-sided polygon with exactly one pair of parallel sides. So here usually it's the top and bottom that would be the parallel sides, or the base and the top. So AB here is parallel to DC. So that's how you know it's a trapezoid. Now, it's trapezoid if it only has one pair of parallel sides. So these two sides would not be parallel. If they were, then we would just call it a parallelogram and then classify it if it's like a rhombus, rectangle, or square. So the non-parallel sides are called the legs. So here that would be AD and BC. And then the parallel sides are called the bases. And those are the ones I marked with the parallel marks. So each trapezoid has two pairs of base angles. So D and C are base angles. So angle D and angle C. And then angle A and B are base angles. Now, even though they're base angles, they are not necessarily going to be congruent, but if they are congruent, then we would call it an isosceles trapezoid. So an isosceles trapezoid is a one in which first of all, the legs are congruent. So it has congruent legs. So here, if we name this trapezoid ABCD, and if AD is congruent to BC, then it would be an isosceles trapezoid. And then there are two other properties of the isosceles trapezoid. One is that each pair of base angles are congruent. Each pair of base angles are congruent. So A and B would be congruent, and then D and C would be congruent. And also, we have to always talk about the diagonals. So the diagonals are also congruent in an isosceles trapezoid, but not necessarily in a trapezoid that's not isosceles. Okay, so let's draw the diagonals. So the diagonals, they're not angle bisectors. They're not bisectors of each other. They're none of that. The only thing that we can really say about them is that they are congruent. And so that would be, well, I don't even want to say that just because I don't want to confuse you and think that just this part is congruent. So anyways, let's do some practice with this. So a little theorem related to trapezoids is called the midsegment. So the midsegment of a trapezoid is a segment that connects the midpoints of the legs. So say we have the midpoint of AD, the midpoint of BC, and this is just a regular trapezoid, not isosceles. And the midsegment would be the segment that connects those two midpoints. My diagram's a little bit off, don't worry. It is parallel to the bases, and its length is 1/2 the sum of the lengths of the bases. All right, so let's call this XY. So first of all, if X is the midpoint of AD, we know that XD and XA are congruent, and then BY and BC are congruent. But I'm going to give them 2 tick marks because we don't know that they are congruent to AX. We just know that it's congruent to the other part of the midpoint. So, or of the other part of the leg. So then you know that XY, the midsegment is parallel to AB and to DC. So all 3 of those would be parallel. And they said it's 1/2 of the sum of the lengths of the bases. So here's a little equation we could set up. XY is equal to 1/2 of, if you were to add up AB and DC and multiply it by 1/2 or divide it by 2. So another way you could write this is AB plus DC over 2, Be careful if you're doing this on your graphing calculator, though, that you put parentheses around the AB and the DC, or you put it into like a fraction bar, or you just do it in individual steps. Okay, so the other way you could write this equation would be to multiply xy by 2. So you could do 2 times xy equals the sum of AB plus DC. All right, so now let's see if the following is a trapezoid. So do we have enough information to say if it's a trapezoid, and if so, would it be isosceles? So here, if alternate interior angles are congruent, then we know that these segments would be parallel. And if we know that those segments are parallel, then we know that it's a trapezoid. So this would be yes. Now, is there enough information, though, to prove that these two sides are congruent, or that the base angles are congruent? No, not enough information for that. Okay, determining the missing angle measures. All right, so this looks like an isosceles trapezoid because you've got one pair of parallel sides and then one pair, and then the legs are congruent, so that matches. So that means the base angles are congruent. Now be careful because this is flipped on its side. So the base angles would be A and D and B and C. So then the measure of angle D would also be 97. And then to figure the measure of angle B and C, we'll do some math with 360. So I would add up the 97 times 2, subtract it from 360, and then the result of that you'd have to divide by 2 to get the measure of each base angle. So 97 times 2, what did I do, x, is 194, and then 360 minus 194 gives us 166, divided by 2, and that means each base angle for B and C would be 83. I'm going to say the measure of angle B equals the measure of angle C, which is 83 degrees. All right. Now we're using the midsegment of a trapezoid. So to figure out the length of the midsegment, we would add up 7 and 13 and divide it by 2. So we'll do 1/2 of 7 plus 13 would be 20, so that would be 10. All right. Now here it's a little bit trickier because you're going to have an equation to set up. So let's use the format of what we wrote on the other page and say that the midsegment 20 equals 1/2 of 17 plus 7x minus 5. Or I'm going to do actually 7x minus 5 plus 17. All right, so let's simplify our equation. So we've got 20 equals 1/2 times 7x, negative 5 and 17 make plus 12. Now, there are a couple different ways you could do this. You could distribute the 1/2, but since 7 isn't divisible by 1/2, that might just make it more complicated. So what I would actually do is take the 1/2 and multiply it by 2 on the other side, because 2 over 1 would cancel with the 1/2. Okay, so this would become 40 equals 7x plus 12, and then two-step equation. This would be 28 is 7x, so x is 4. And now if you're not comfortable doing the times 2, then just go ahead and distribute. You'll get the same answer. All right. So for this one, this is also a trapezoid, and here this is the midsegment. So we can set up the equation again. So we'll do, and I'm going to just go ahead and do that second equation I showed you, the 2 times 17.1 equals 8x plus 3.2 plus 2x. So this would be 34.2, 10x plus 3.2, and I'm not sure how I'm supposed to, there we go, minus 3.2 gives us 31, so x is 3.1. Right, so here the sum of the two bases of a trapezoid is 3x plus 21. The midsegment is 3x plus 3. Find the length of the midsegment. All right, so they're giving us the sum. So I'm going to say 2 times the midsegment equals the sum. Okay, so then I'm going to distribute the 2. So 6x plus 6 equals 3x plus 21. And then let's solve for x. So this would be 3x is 15, x is 5. Now once you get x equals 5, then you would plug it into the length of the midsegment. So 3 times 5 plus 3 gives us 18. So the length of the midsegment here would be 18. All right. And then explain the difference between a trapezoid and a parallelogram. Well, a trapezoid can only have one pair of parallel sides, but a parallelogram has to have 2 pairs of parallel sides. So that's the difference. And then determine if each statement is sometimes, always, or never true. Trapezoid is a parallelogram. Actually, I'm going to let you guys do this one in the Edulastic tomorrow. Okay, so if you wanted to get a head start about thinking of this, you can pause the video and write what you think your answers are, but I'm going to skip it for now. All right, so how about a kite? So the kite is the next thing we'll learn about. Is a quadrilateral with 2 pairs of consecutive congruent sides. So we've never had, well, besides a square, we've never had consecutive congruent sides. But if all 4 sides are congruent, then we would call it a square. Well, as long as you have right angles. If not, then it would be a rhombus. But anyways, if you have 2 pairs of consecutive congruent sides, then it's called a kite. But what really makes it a kite and not a rhombus or a square is that opposite sides are not congruent. So this side is not supposed to be congruent with that side, and vice versa. All right, so let's think about this. Are the consecutive angles supplementary? So would this be supplementary with that one? Not necessarily. We're going to say no for that one, and we'll look at why. What do you know about the sum of the interior angles? It's still going to be 360 degrees. And then let's talk about the diagonals. The kite's diagonals are perpendicular. They're obviously not congruent. We'll talk about whether they're angle bisectors or not, but they are definitely perpendicular, which also means that you've got right triangles. All right, so here's another thing. If a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. But you've got to be careful which ones you're talking about. So are we talking about M and T or A and H? We are talking about A and H. Because here's the thing. If you were to split this up into if you were to draw this diagonal MT, then you've got 2 congruent triangles by side-side-side congruence theorem, which means that the corresponding parts are congruent, so A and H would be congruent. So M and T would not be congruent. Now, this would be congruent with this part, and this would be congruent with that part. So then you've got that one of the diagonals is also an angle bisector, but this diagonal would not be an angle bisector. So it's a little bit tricky to think about. But make sure you write all this down so you don't forget. So we're saying that this figure is a kite. So what is the measure of angle Q? So the way we're going to figure this out is we're going to subtract 83 and 41 from 360. So maybe if I add those up, I get 124. If I take 360 minus 124, it's too early to do mental math. Well, it's never too early to do mental math, but 236. Okay, so then I'm going to take 236 and divide it by 2. So then we would get 118 degrees for Q and S. Number 2, in a kite, the measures of the angles are those. Find the value of x. What is the measure of the angles that are congruent? right, so let's just take all 4 of these and add them up to be 360. So, well, actually, what I can do, I mean, there's lots of different ways you can do this. You can take 360 and subtract the angles that you're given. So minus 126, minus 84, minus 24, and then we're left with 176 equals 6x, so you would divide this by 6, and you get x's, well, what did I do wrong? I feel like that's not the answer that we got here. Well, that looks like the right answer. Maybe I can't figure out what I did wrong. 190. Oh, I added 24. Okay, let me go up here. Minus. Okay, divide that by 6, and you get 21. All right, that's better. So x is 21. So that means that this angle would be 6 times 21, which gives you back to 126. Okay, so if that is 126, then this is also 126. So the measures of the angles that are congruent are 126. All right, a few more examples I'm just going to walk you through. So this says Kate is a kite. Angles C and K are opposite angles. So they're saying if C is 90 and K is 100, find the measure of angle A. So you would subtract those from 360 and divide by 2 to get the measures of angle A, because these would be the 2 angles that aren't congruent. Number 4, Pqrs is a kite with diagonals intersecting at T. All right, so now we're working with some right triangles. What kind of, oh, oops, I think I gave you part of the answer. Well, what kind of triangle is PQT? So this is T, PQT. So it's not just a right triangle, but it's an isosceles right triangle. Right triangle. Find the exact perimeter of PQRS. So if you wanted to find the perimeter, you would need to use Pythagorean theorem, or you could use special right triangles to find these. So PQ would be 4 square root 2, and then 4 square root 2, because if this is 4, then you got 4 square root 2, 45, 45, 90 triangle. And then for these two triangles, 4 and 8 are two sides of a perfect, spit it out, of the perfect, Pythagorean triple, sorry. So 2, 4, 5 triangle is also a 4, 8, 10 triangle. Or you could just do Pythagorean theorem if you didn't remember that. So this would be 4 square root 2 plus 4 square root 2, and then plus 20. So you would simplify this as 8 square root 2 plus 20. So you wouldn't add the 8 square root 2 and the 20 together because the 20 doesn't have a square root 2. It's kind of like they're not like terms. And then the measure of angle QRS. So QRS, this angle here. So this is an important question. I believe there's a question like this on your test. So what you want to do is first figure out this angle by using a trig ratio, and I would use the tangent because you've got opposite and adjacent. So I'm going to say the tangent of, well, the tangent inverse, because we're finding the angle, of 4 over 8. Okay, so let's figure that out. If you type that in your calculator, I'm going to check the modes in degrees. So the tangent inverse of 4 over 8, which is 1/2, is 26.5. We'll just call that 26.6. But then to get the whole entire angle, you would divide it by 2, since this along here is a angle bisector. So times 2 would give you 53.2 degrees. Now be careful, because if they ask you for a PQR, you would find this angle, well, this would be 45, but you can't just divide 45 by 2 because this would be different. So these two angles are different. So you would have to use 2 trig ratios if it asks you for PQR. But it asks us for QRS, so we could just find 1 and multiply by 2 because these two are the same. Because only one way of the diagonal makes angle bisectors for a trapezoid. All right. And then the next question I will put in the edge elastic. It's just finding the lengths of the sides of the kite. So you're just using Pythagorean theorem for this one. And then it's also going to ask you to find ITE. So you would do just the same process, do the tan inverse of 2 over 6 and multiply by 2. All right, so I'm going to stop the video there. You guys have a great day.